Hello all. So today in this video, in the previous video, you would have seen that we have make some improvements. That is previously with while working with 80 images, we got only 21% accuracy. But while working, just increasing the size, we got nearly the accuracy, which I'm meaning is I'm saying it from this performance metric. So mostly every time we will just take the accuracy value from here, right? So it will be better to just take from here. So only I am just choosing it from here. So we can just stack. So in the previous video itself, I would have said that we are using only 5 layers. So in this thing, we can just stack the number of layers. For that, I am just stacking the 2 layers. Convolution 2D layer. I'm copying it and just pasting it. So here we don't need the input size since we have already called it. So I'm deleting it. Apart from that, everything is okay. So now we can train the CNN model again. And again, we can just put into the run the approaches for 20. If you need some other more approaches means you can just train, no issues. So 20 approaches we have completed. So then we can move to the loss graph plot and also accuracy graph plot. So previous without the stacking layers we got 24. So now we can see now also it's 24, not that much big variation. While stacking the layers, we can just increase this number. Then we can just compile and train the model. It's training. Only 1% it's increased, but it's increased. So this is another step that is by stacking the layers. So we can also stack some more layers. The same convolution 2D and max 2D. Here also I'm just increasing its number to 64. Now we can run. Already we got nearly 27% accuracy in the performance plot. That is while working with the performance metrics calculations like precision, recall and F1 score. Now also we can check with that itself. It's increasing, but it's not vast, but it's increasing. So by simple steps, we can just increase. So in the next video, we will show how to increase it by adding some more layers apart from convolution layers like batch normalization layer, dropout layer, etc. Since those layers are responsible to increase the that is reduce the overfitting. This accuracy drop is due to the overfitting issues, mainly due to overfitting issues. So dropout layer and some kernel batch normalization layers are responsible to reduce that overfitting layer. So we can just see some demo in the next video by how to use this batch normalization layer and dropout layer, and also some more dense layers, and also by increasing the number of filter size in the dense layers we can also increase the accuracy. So we can see some other more steps in the previous in the upcoming videos. Thank you.